Alright guys, this is the hyperbola video, and I cut out that little thing, the little picture of the conic. Remember, if you took two cones, put them point to point, cut them perpendicular to the base of the cone, you will generate an upward U over here or a U over here. You would. But what would happen if you laid these two cones flat? Well, then you'd create a different looking hyperbola. See, here's the deal. Hyperbolas, when you graph them, will either do this, or they will do this. You got two different orientations. You have two different orientations. So every graph that I'm going to draw is either going to do this thing, up and down or side to side. Now I have a little fresh rhyme to remember how they're going to go, but it has to do with who's negative. See, in a circle, this is always a plus sign. In an ellipse, also a plus sign. In fact, if I left that plus sign right there, this guy is an ellipse. But let's get rid of that junk. Boom, boom. It's not. It's a negative. So if the y portion of the problem is negative, you get one type of look. If the x portion is negative, you get a different type of look. So these ones are going to take a little bit longer, but they're not difficult just to sketch the graph. But what I'm about to do, you're going to go, that's pretty bizarre. But guess what? That's the way you do it. So here we go. If the x is first, this is going to control x motion. That is totally true. So guess what? I'm going to go right 2 units, left 2 units. It's the same concept we use with an ellipse. The number under x controls the side-to-side motion. So guess how many units I'm going to go up and how many units I'm going to go down? The answer is 3. But is this going to draw this picture or this one? Well, if y is negative, it's going to open sideways. If x is negative, see this next example? The ellipse is going to open up and down. Here's how I remember this. When you draw an ellipse out, you either have the x first minus y stuff, or you have the y stuff minus x stuff. That's how we write them. That is how you write an ellipse equation. So I always say x before y, x before y, open side to side. But what about y? Well, what if it's y before x? Well, y before x, open, open up and dex. Now, the word down doesn't rhyme with x, and I like my rhymes to be fresh in a dope fly way. So I made up the word dex. So x before y, open side to side. So that means my graph will have this look to it. Y before x, open up and dex. So my graph will have this look to it. That's how I remember the orientation, or which way the shape is pointing. So now that we've done the little fresh rhyme thing, x before y, open side to side. Y before x, open up and dex. We're going to do this one. So let's get some room. I'm going to get rid of all of this junk in my way. Oops. Let's see. Cut. Yes. Let's just clean this up a little bit. Get out of my face. Out of my face. So here we go. This is a hyperbola, which is centered at the origin. What if it's not centered at the origin? I'll do one of those too so you can see the difference. But if the center is at the origin, it's really easy peasy. I'm going to count 2 to the right, to the left. What am I going to do here? Up 3, down 3. Now here's where you just got to trust me. I am not going into severe details here. I told you I wouldn't. I just want to make it so that you know how to graph these. So I'm going to draw a box. I'm going to draw through all of these points. Do you see how I'm connecting through all of my dashes? I'm going to draw a box. Why? Because that's how we do it. Then what I'm going to do, I'm going to use a different color. I'm going to use red. I'm going to connect the diagonals. I'm going to go like this. I'm going to go through this corner of the box, through that corner of the box. I'm going to do that over here too. And you might say, why? Why am I doing this? You want to be able to graph hyperbola. Now, x before y, open side to side. So here's how we do this. This guy right here goes like this. Oh, yeah. This guy right here goes like this. The blue part of this graph is the hyperbola. All this other stuff is just markings to help me draw it correctly. And as you can see, that was sideways 2 units right, 2 units left. Guess what? Those are called the vertices on this. The vertices are at positive or negative 2. Those are it looks like a double-sided parabola, but we don't call it a vertex if there's 2 of them. We call them vertices. Also, the red lines, guess what? Those are asymptotes. So the blue graph is trying to approach those red dashed lines, but guess what? That's how you draw this picture. I know at first you're like, what? But it's an easy thing to do. It's not difficult to do. We are not going into detail. Remember, the question on the AP Calc Summer Packet says, sketch the graph. So guess what? You just sketched a graph with me. Let's look at this next one, and then you'll see it. I have 3 more examples, and then you'll go, I got it, and you'll just do it. You'll turn this video off. So here we go. Here's my other one. Y before X. Open up and dex. So here we go. I'm going to go back to my black pen. And I'm going to say, I'm about to sketch a graph that's a hyperbola, but instead of going sideways like the last one, this one's going to go up and down. Still, this controls y motion. It's underneath y. So I'm going to go up 3. Well, wait a minute, I did that in the other one. I'm going to go down 3. Yeah, same thing. This controls x motion. I'm going to go this way too. I'm going to go this way too. I'm going to draw a box. Yep, you sure will. Because that's what we do to sketch a hyperbola. We sketch a box. Then we're still going to do the red line for the asymptotes. Yep. Okay, let's grab a blue pen. But this time, y before x, open up and dex. These guys are not my vertices this time. No way. They are not. They are not my vertices. These guys are. Why? Because the y value is positive, the x value is negative. Oh, really, that's why. That is the reason why. But here we go. I'm going to sketch the graph going this way now. I am. That's what I am doing. Senors y senoritas. Now, these 2 graphs are supposed to be perfectly matched. They're supposed to be congruent to each other, but one goes up, one goes down. But, you know, I'm drawing this to the best of my ability freehand. But that's why you use all the guidelines that you can. The red lines in there, those asymptotes, help you sketch the graph as good as you can. But, once again, what did I graph? A hyperbola. How do I know it's a hyperbola? Because there is a minus in the middle, not a plus. And this one went sideways. Why? Because there's a minus in the middle, not a plus. And who's positive here? That is how you get it done. All right? Now, let's play with this one. What? they don't have one like this on the summer packet. No, they don't. But I want to make sure that you know this because it's good practice. Because we just talked about circles. We've seen parabolas. We've seen ellipses. So hyperbolas can have a center that is not at the origin. Where is the center of this hyperbola? Well, it's going to be at -2, 1. Remember? -2 would be x motion. Y would be -1, y motion. So I'm going to sketch this graph. Come on. I'm going to give it one more try. Sketch this graph. There you go. But I'm going to start at -2, 1. That's going to be the center of my graph. But you know what I'm going to do for x motion? I'm going to go 1, 2, 3, 4 units away from there. That's what I'm going to do. I'm going to go 1, 2, 3, 4 units away from the center. That's my x motion. What's my y motion? I'm going to go up 1, 2 from the center. I'm going to go down 2 from the center. Guess what? My little guys, all my little guys here, I'm going to draw a box through it. I'm going to go boxing through all of these guys. I am now going to get my red pen because I'm about to sketch in my asymptotes. And is it x before y or is it y before x? It's x before y. Open side to side. So here is one of my vertices. Here's my other vertice. I am giving you guys a crash course in this. I am not going through a lot of detail. Why? But why? But why? The problem on the packet does not ask you any more than sketch the graph. So that's what I'm just trying to get you guys to be able to sketch a graph. So here we go. See this one? I'm going to do this one, and then you're going to do the one on the packet. See, on the packet, see this guy right here is a hyperbola. This is one of these weird draw the box, diagonals, all that stuff. And then, well, y before x, wait a minute, something looks different about this. Whoops. You're correct. Something totally looks different about this. But let me show you my example, and then we'll talk about how you're going to get your problem done. So here's my example that I made up. See, here's the thing with this. This does not look like the other ones. And you cannot sketch this graph easily until you get it in the proper format. So what's the proper format? You got to have an x and a y and it equals 1. You got to have a y and an x and it equals 1. You got to have that thing so it equals 1. That's the key. So let's make this thing equal 1. Well, how do I make it equal 1? Well, let's divide everything by -36. If I divided every piece of this by -36, that's going to be a 1. What's it going to equal? Well, let's reduce this fraction. That's going to be x squared over -4. And then a double minus, that makes that a plus, and I'd get, let's reduce it. Y squared over 9. And then I go, wait a minute, something doesn't look right to me, because this looks like an ellipse with a negative in the bottom. You guys know you can put a negative in the top, bottom, middle, whatever. So I'm going to put the negative up here. And then I'm going to say, you know what? Let's rearrange this. These guys are in the wrong order. Because what am I after? I'm after y before x, open, up, and dex, y'all. Y before x, open, up, and dex. I think we did this one already. Oh, y squared over, what? There it is. See, if they don't give it to you in what's called standard form, you got to go get it. So that one was in standard form. Well, what about this stuff? That's standard form as long as it says equals 1. You got the positive information first, you got the negative information second. This one just has a different center. But the one on the homework they gave me looks like this. So guess what? Let's play. 9y squared equals 25x squared plus 225. Now, I'm not going to do this for you, but I'll get you started. We want to have all the x and y information on one side. So guess what? I'm going to take this away and move it to the other side. I could do that. It's okay. If I did that, I'd put it over here, right? La, la, la. Goodbye. Now, ask yourself, should I say negative 25x squared plus 9y squared? Or should I say 9y squared minus 25x squared? That's what I should do. Because it's always the negative or the minus sign is supposed to be between the two quantities. Equals, what's left over here? I didn't touch that, did I? But it still doesn't look like it's standard form, because standard form, I would want this to be 1. So I'm going to do this. I'm going to do this. I'm going to do this. And then that's 1 equals, and then guess what? I would imagine that 25 to 25ths, I would imagine you could reduce this. I would imagine you could reduce that. I would, because guess what? I'm not doing this problem for you, but I'm showing you how you make something that looks like this into something that looks like this. And I already did an example like that for you. I am trying to get you close to the end without doing the problem for you. But here's the big magic thing in all of this stuff. You have many different things where you'll have an x squared and a y squared in them. Or x squared, y squared with like pluses in the middle, things like that. Or in this case, when I move this over, a minus in the middle. So your job is to recognize what makes something an ellipse, what makes something a circle, what makes something a semicircle, what makes something a hyperbola, and then you can sketch its graph because you know how to manipulate the variables. All right, now the instructions right here said graph each. So if you want to graph them, that's what the last 4 videos were all about, to help you get through this section of the AP Calc summer packet. All right. Now, since this is the last video I'm showing you guys, I did want to share with you, Miss Quigley told me that the summer packet, you should start working on it now. You should complete it now. And then let your brain cool off a little bit. But August, like the beginning of August, go back through it. Go back through this thing and do it again. Make sure you're geared up, and notice that there's a lot of formulas in those sheets. I said this to you guys, make flashcards. Get that stuff back in your brain. You need to have stuff like, hey, I recognize you, buddy. I got a formula that I have memorized, sure do. What is the, arithmetic rule? What about that, huh? Arithmetic rule. You mean a sub n equals a1 plus n minus 1 times d? Yeah. All of this stuff that I told you guys throughout the trimester. Make yourself some flashcards so you don't forget any of these important little doodads so that you're ready for AP Calculus. You've already done the work. You just have to refresh your memory about the formulas and things. Okay? And stuff like, hey, what about log base 4 of 4 to the 7th? I wonder what that equals 7, right? Get that stuff back into your psyche. But her word to me was, you will not be taking the test on this packet the very first day you come back. it will be the very next week. So she's going to let you guys not work on it, but ask her questions during the first week of school. Then you take the test on the AP Calc Summer Packet. Okay? So I thought I'd throw that at you and say, if you never watched any of these videos, then you don't know any of that information. Kind of weird, because if you're watching this, you know that information. All right, that is the end. That is video 8. Have good luck trying to sketch all this stuff out and do all this stuff. Bye-bye for now.